Good morning, students. Today I will continue of the cases for the convex mirror. Okay. So in the previous video I have already completed the cases for the concave mirror. Today I will start from the convex mirror, and I will provide you a chart and a trick which I have not told in the previous video. Today I will complete this. Okay. So let us begin. So for the convex mirror, there is two cases only. First case is that if the object is at infinity, then the image will formed at the focus. This is the image size will be the diminished, and it will be virtual as well as erect. And except the infinity, if the object is placed anywhere in the between the infinity and pole, then the image will form between the pole and the focus. So wherever I will place this, suppose here or here, so the image will be formed only and only here. Okay, in between this pole and focus. Always it will be virtual and erect. Okay. So what will be the sign convention for the solving of this problem? Okay. So take this chart. Okay, before going to the chart, I am telling one thing is that if you have studied this part pretty well, so you have also noticed a particular pattern of this. If the object is at infinity, then image is at where? Focus, right? So if we are going for the object from infinity towards the focus, and then the image will comes from this way to this. So this is the basic thing. If the object is at infinity, then the image is formed at focus. First condition. First case basically. Second case, if the object is in between infinity and the center of curvature, then the object is formed in between focus and pole. Sorry, focus and center of curvature. Object is at center of curvature, image will be at center of curvature. Okay. Object is at focus, or object is at in between center of curvature and focus, image is behind the center of curvature. So the thing is that as we move the object from infinity towards the focus, the image is moving from the pole or from the focus towards the infinity. So this is the basic way or basic pattern of this object and image relation. So if you remember these things, then it will be pretty easier for you to remember all these characteristics or all the positions basically for this for the reflection of the spherical mirror. Okay. So let us continue with the chart, sign convention. First I am writing the concave mirror form. Okay. For the concave mirror we are getting two things, that is first one is real image and next one is virtual. Two kind of images we are getting. So for the real image, the condition is basically u greater than equal to f, that is object distance will be greater than equal to the focal distance, and for the virtual, object distance will be less than the focus. Okay. So here for the real case, u will be negative, v will be negative, focal length will be also negative, height of the object, that is O, it is positive, height of the image, that is I, this is negative, radius of curvature, that is R, this will be negative, as well as magnification M, this will be also negative for the real part. For the virtual part, U will be negative, V will be positive, F will be negative, object distance will be positive, height of the object, height of the image, that will be also positive, radius of curvature will be negative, magnification will be positive. So this is the chart which helps you to do the numericals. Okay. For the concave, this is exclusively for the concave mirror. Okay. Next I am coming for the convex mirror. For the convex mirror, U is negative, V is always positive, F is always positive, object height is always positive, image height will be positive, radius of curvature will be positive, magnification is also positive. So for the convex mirror, always we are getting the virtual image. So no concept of the real image for the convex mirror. That's why one condition for the virtual only. Hopefully it is clear to you. Now coming for the magnification part. So what is magnification? Already you know that magnification is nothing but that is m equals to minus v by u. Already I think you know this. That is distance of the image by distance of the object, and why this minus will come, you also know this. No problem at all. Now coming for the next part. So that is that by the mirror formula. From the mirror formula, what is the mirror formula? That is 1 by v plus 1 by u equals to 1 by f, right? So from here, if I am adjusting this v, okay, is it possible to write like this? Why? I am multiplying these both sides by minus v. So what I have done here, I have multiplied by minus v both sides. So if I multiply it with minus v, so it will be minus 1, it will be minus v by u, it will be minus v by f, right? So therefore, what will be minus v by u plus 1? Okay. So if I generalize this, what we can conclude? It becomes no problem at all. So what is this minus v by u? That is basically nothing but our m, that is magnification. So this is another formula for the magnification, that is m equal to f minus v by f. Okay. So what I have done here, I have multiplied this equation with minus v. The same thing I will do, but with the next order, that is I will multiply this equation with minus u. So what will be this m? M will be basically, if you evaluate this, so it becomes this. Okay. So the magnification will be negative when the image is inverted and the positive when image is erect. Already you know that. Now, what will be the concept of this magnification in terms of the derivatives? Let's see. So if an object is placed with the length along the principal axis, so it is called basically the longitudinal magnification. Okay, so how you can represent this longitudinal magnification? The longitudinal magnification ML can be defined as I by O, that is image height by object height. So what is this image height? Image height can be written as V2 minus V1 and object height, that is U2 minus U1. Why I have given this? Basically, when we are considering an object, so suppose I am considering this is the U2 position and this pole has the U1 position. So what will be the distance of the object from the pole? That will be U2 minus U1. Hopefully it is clear. That's why all magnification can be written as minus V by U. What is V? V is the object image distance and U is the object distance. So instead of writing U, I am writing U2 minus U1. And instead of writing V directly, I am writing V2 minus V1. What is this V1 position? V1 basically I consider as pole. Okay. So I can write like this. So basically this is the change in the image distance corresponding to the change in the object distance. So therefore, for small object I can write it as dV by du. Hopefully it is clear to all. That is dV by du. Okay. So now according to the mirror equation, 1 by V plus 1 by U, that is equal to 1 by F. So partial differentiating, V minus V to the power minus 2 du, sorry dV minus U to the power minus 2 du, that will be 0. Differentiation of differentiation of V with respect to U and differentiation of V with respect to U. Okay. So from here, what we can write? Or I am writing dV du, that is equal to minus U to the power minus 2 by V to the power minus 2. From there, what we can write? dV du, that is equal to minus V by U whole square. In the previous part, what I have already done, that is dV du is nothing but m. So this m I will put here. So basically comparing dV du that is ml, basically longitudinal magnification, that is minus dV du, that is basically V by U whole square. What is V by U? V by U is nothing but minus m. So if you do the minus m square, so it becomes m square. So longitudinal magnification ml is the square of the linear magnification. Okay. So this is the general relation between the longitudinal magnification with respect to the linear magnification. Hopefully it is clear to all. In the next video, I will continue with the refraction of light. Thank you.